Now, we'll start with a quick revision of trigonometry before we get started with 2 past paper questions. So, grade 11 trigonometry. Now, something extremely important to remember about trigonometry is SOHCAHTOA. That expression will help you to remember what each identity is equal to. So let us have a look at SOH. Now, the S represents sine, the O represents opposite, and the H represents hypotenuse. The C represents cos, the A represents adjacent, the H represents hypotenuse. Excuse me. If we have a look at T, the T represents tan, the O represents opposite, and the A represents adjacent. Now, how do we know which is the opposite, hypotenuse, and adjacent of our triangle? So how we do that is we look at each side in relation to theta. So if we look at our angle theta and we look at the side opposite that angle theta, that is going to be our opposite side. So this will be our opposite. If we look at the side opposite the 90-degree sine, that is going to be our hypotenuse. And the side that is under theta, or the leftover side, will be known as your adjacent. So I'll repeat once more. How we identify the opposite is from its namesake, it is the side opposite theta. How we identify the hypotenuse is it is the side opposite the 90-degree angle. So all you do is put your pen on the tip or on the corner of your 90-degree sine and run it across, and that'll be your opposite. Then the leftover side, or the side under theta, would represent your adjacent. So that is how you identify those sides. It is extremely important to know which is the opposite, adjacent, and hypotenuse before you get started with your triangle, if you are using or if you are dealing with a diagram question or any question involving a triangle. If you don't know which are your sides, it's likely that you are going to get the question wrong. So let us start. We've got sine theta. Now we know that sine theta, as we said previously from our SOHCAHTOA, sine theta is equal to our opposite over our hypotenuse. Cos theta from our SOHCAHTOA is adjacent over hypotenuse. And tan of theta is equal to opposite over adjacent. Now, within a 90-degree triangle, we've got 3 angles. We've got our angle theta, we've got our angle of 90 degrees, and we have this additional angle, this third angle. It is also possible for us to find sine, cos, and tan of that third angle. So that third angle is going to be 90 minus theta. Now let us prove that it is 90 minus theta. So if we were to add up each angle within this triangle, let's call this angle L. Okay, so if we add them up, let's say angle L plus theta plus 90 degrees, and we know that a triangle, all 3 interior angles of a triangle add up to 180 degrees. Now, if we simplify and solve for angle L, what are we left with? So what we're going to do is we're going to take theta to the other side, and we're going to take the 180 to the other side as well. That will leave us with angle equals 180 minus 90 minus theta. Keep in mind that when you move a positive value to the other side, it becomes negative. This will then give us our angle as equal to 90 minus theta. So this angle now represents 90 minus theta. So we can now find sine, cos, and tan of that angle 90 minus theta. Now, in order for us to do that, we need to now go back and label our sides of our triangle because it's not going to be the same. The opposite, adjacent, and hypotenuse of theta is not the same hypotenuse, opposite, and adjacent of our angle L. The reason is that those previous sides were in relation or in reference to theta. Those sides were in relation or in reference to theta. Now we need to go and obtain the new opposite and adjacent with reference to angle L. So I'm going to use a white pen so that you can see the difference and you don't get mixed up between theta's sides and angle L's sides. So which is the side opposite angle L? That is the side over here. So it's going to be known as the opposite of L. So we can put a tiny L in bracket to show that that is in reference to L. Now, the hypotenuse is still going to remain the same because the 90-degree angle has not changed or moved. So that hypotenuse is still opposite the 90-degree sine. It does not change. Let us put in a small theta over here to show that this is with reference to theta. If we look at the side that is under L, that is going to be the adjacent of L. So what we did previously, we just repeat the process, but for a different reference point, for a new angle L. So let us go and substitute. It's still the exact same thing. Our sine of 90 minus theta is still opposite over hypotenuse. It's just of a different side. Our cos is still going to be adjacent over hypotenuse, and our tan will still be opposite over adjacent. Now, there's something quite interesting about sine cos of 90 minus theta and 90 plus theta that we will explore a bit later on. So let us move on from this part. So our cost diagram. Your cost diagram is something that is extremely important when dealing with trigonometry. In order for you to successfully analyze and answer a trigonometry question, you need to be familiar with your cost diagram. Now, please take note that your cost diagram is not given to you on your question paper. It is something that you have to know or memorize, or however you feel that it's best for you to remember it. I would recommend learning it, and then when you get to the exam, write it at the back of the paper so that you can use it as a reference, or you can always go back to it. It makes it easier. So our cost diagram, we've got quadrant 1, 2, 3, and 4. Now, each quadrant is broken up into 90-degree sectors. So if we look at quadrant 1, you can see that quadrant 1 is from 0 degrees all the way to 90 degrees. Now, within quadrant 1, we've got all three identities as positive. What that means is that sine of theta is positive, cos of theta is positive, and tan of theta is positive if the angle is between 0 and 90, meaning that it is within quadrant 1. In addition to that, in quadrant 1, we have our three reduction formulas. So we've got angle. So if it is between 0 and 90, you won't reduce it because it's already been reduced or it's already simplified. So you can leave it as that. That is why it's represented as angle. In addition to that, we've got 90 minus theta. Now that is a co-ratio, or some people like to call it a co-function. What is important about that is that 90 will convert a sine to a cos or a cos to a sine. So that is important. Those types of questions are frequently asked within an exam paper. That 90 has the ability to change the identity from a sine to a cos. It's based on what we previously discussed with the third angle. And lastly, within quadrant 1, we've got 360 plus theta. Now, this identity is seldomly used, meaning that it is not frequently asked. However, it is important to know it. All this means is that once you reach this point here, that's 30, that's 360. If you go beyond that, or if you add an additional angle, you go into a sector of 360 plus some additional angle. Okay. So those are the three reduction formulas that you should know, and it is very important for you to know that. Now, next we have quadrant 2, which is this area over here. Now, quadrant 2 is from 90 degrees all the way to 180 degrees. Now, within quadrant 2, keep in mind that only sine is positive, meaning that cos and tan are negative. Always remember that. Now, our reduction formula within quadrant 2 is 180 minus theta, and our co-ratio of 90 plus theta. Let us move on to quadrant 3. Quadrant 3 is 180 degrees until 270 degrees, and within quadrant 3, only tan is positive, which means that sine and cos are negative. And our reduction formula within quadrant 3 is 180 plus theta. So please don't get confused between the reduction formula of quadrant 2 and quadrant 3. Within quadrant 3, the reduction formula is 180 plus theta. Within quadrant 2, the reduction formula is 180 minus theta. So be careful with that. Now, if we go to quadrant 4, we now have 270 until 360. And within quadrant 4, only cos is positive. That means that sine and tan are negative, and our reduction formula for quadrant 4 is 360 minus theta. So keep that in mind. Now, how we remember which identities are positive and which are negative is based on the name of the diagram, cost diagram. C representing that cos is positive, A representing that all are positive, S representing that sine is positive, and T representing that tan is positive. Whatever letter is within that quadrant represents which identity or identities are positive within that specific quadrant. Now, something important to take note of is that when we are dealing with a positive cost diagram, our angles are going to start at 0 degrees and move in an anti-clockwise direction. If we were dealing with a negative cost diagram, our angle would move in a clockwise direction from 0 moving clockwise. So this would have then become 0, negative 90, negative 180, negative 270, and negative 0 if we were dealing with a negative cost diagram. So let's move on from that. Before we actually move on, you'll see when we do past paper questions, you'll see how frequently we'll scroll back to this cost diagram to make use of it. So I would highly recommend that you go and learn this cost diagram. If you are interested in learning the negative cost diagram as well, which is important in grade 11, I think you are assessed on that. There's a video that I've uploaded on how to convert from the positive cost diagram to the negative cost diagram. That way you won't have to memorize both and risk messing up or confusing the quadrants, all you need to do is learn the positive cost diagram, and then you can use a simple trick to convert from the positive to the negative. Okay. Now, I previously mentioned that we would discuss co-ratios. Now, let's try and see if we can get our cost diagram and our co-ratio topic within the same frame. Okay. Now, if you look at the first co-ratio, you've got a sine of 90 minus theta. So 90 minus theta is in which quadrant? That's the first question we ask ourselves. Which quadrant is this thing located in? Now 90 minus theta, as you can see, is quadrant 1. And now we ask ourselves, is sine positive or negative within quadrant 1? And sine is positive, so you put a plus sign. That's the first step to converting to using a co-ratio. Now the next step is, because we have a 90, because it is a co-ratio, we just write the other identity. So you've got two identities, either sine or cos. So because we are dealing with sine, that means this is going to change to cos. That is how we get positive cos theta. So we ask ourselves two questions. Which quadrant is this thing in? And is it positive or negative within that quadrant? And you write that sign. Your third step is to change from sine to cos or cos to sine. Keep that in mind. The process is very important. Now, next, let's have a look at the second one. So we've got cos of 90 minus theta. So as you can see, once again, 90 minus theta is in quadrant 1. And we know that cos of 90 minus theta is therefore positive in quadrant 1. So we put a positive sign. Next, because we are dealing with 90, because it's a co-ratio, we're going to convert this cos into a sine, making it positive sine theta. So that's the co-ratios within quadrant 1. Let's have a look at the co-ratios in quadrant 2. Now in quadrant 1, it's always going to be positive. In quadrant 2, it's not always positive. Okay, so our first one that we'll have a look at is sine of 90 plus theta, which is located in quadrant 2. And we know that quadrant 2 is where sine is positive, and we are dealing with sine, therefore we will put a positive sign. Next, we are going to convert this sine to a cos, therefore giving us positive cos theta. Something important that you should have noticed is that the sign of this identity being positive or negative depends on the original identity with 90 plus theta or 90 minus theta. What is on your question paper? That original identity determines the sign of whether this thing is positive or negative. Now let us have a look at the last one. This is the one that is negative. We previously dealt with 3 positive ones. So let us deal with this negative. So we have cos of 90 minus theta, and as you can see, this is cos of 90 plus theta, and as you can see, 90 plus theta is in quadrant 2, and we know that cos is negative in quadrant 2, therefore this identity will now be negative. From here, because we're dealing with a co-ratio, we're going to convert that cos to a sine, therefore making it negative sine theta. Now you'll use whatever angle the question uses. For example, if they've used A, B, alpha, beta, theta, X, you'll continue to use that. Meaning if they used cos of 90 plus X, you would have said 90, or rather negative sine x. So always stick to the variable that is used in the question. So let us proceed. So lastly, something important are our identities. Now, these identities are not given to you within your question paper. It's something that you have to memorize or remember before going into your exam. And these identities will make solving questions so much easier. So let's have a look at our first one. We've got tan theta. Now, tan theta is just equal to sine theta over cos theta. Something important to take note of is that the angles have to be the same. We can't have sine of theta over cos of alpha and call that tan theta or tan alpha. It doesn't work like that. The angles have to be the same. For example, if we have sine of 20 degrees over cos of 30 degrees, that is not equal to tan of 20 degrees, nor is it equal to tan of 30 degrees, nor is it equal to tan of 50 or whatever combination you want to create. Because the angles are different, we cannot call it an identity. The angles have to be the same. For example, if we had sine of 20 over cos of 20, that would then be tan of 20 because the angles are the same. It is very important for the angles to be the same. They have to be equal in order for you to turn this into tan. Now, from that identity stems tan squared of theta equals sine squared of theta over cos squared of theta. The reason that we are able to produce the second identity is because we can square the left and square the right without technically changing it or adding anything into it, because it balances out on both sides. What we did to the left, we did to the right. So we are then able to produce tan squared of theta equals sine squared of theta over cos squared of theta. Now, if we look at the last one, you don't have to know this one. It just makes it easier when solving questions if you do. So if you have a question whereby, let's say you've got sine theta on top and you've got tan theta at the bottom. Now, what you can do with this question is just to simply bring down your sine and then substitute sine theta over cos theta. And then simplify like that. Alternatively, what you can do is, because you know that tan theta is at the bottom, which technically makes it 1 over tan theta, what you can do is bring down your sine theta and then swap them. So because you normally know that tan theta is equal to sine theta over cos theta, but in this particular case, you've got tan theta at the bottom, just swap it. So instead of having sine on top, you'll have cos on top. And instead of having cos at the bottom, you'll have sine at the bottom. So all we did was we swapped them around. So it makes it easier to deal with, as opposed to having a fraction in your denominator position. And if you were to square this, it's also true. So 1 over tan squared theta is equal to cos squared theta over sine squared theta. Now, next, we've got the second important identity that you should know, which is cos squared theta plus sine squared theta is equal to 1. Now, there is proofs for these identities that you can have a look at in your textbook. I'm not really going to get into the proofs today because they are quite time consuming, and I would prefer we get to past paper questions as opposed to just dealing with proofs the whole time. I feel it's more beneficial to attempt actual questions. Now, if we look at this identity, cos squared theta plus sine squared theta is equal to 1. This single identity can be broken up into 2 different parts depending on how you want to simplify the equation. So because it's an equation, the same rules apply. We can move things to the other side. So if we were to move sine, or let's say we move cos. So if we were to move cos squared theta to the other side, thereby leaving us with sine only on the left side, that'll give us this first identity. Cos squared theta is equal to 1 minus cos squared theta. If we were to move sine squared theta instead of cos squared theta, thereby solving or isolating cos squared theta, it would then become cos squared theta equals 1 minus sine squared theta. So you can play around with your identities. The most important thing is to remember these two. As long as you can remember them, you can play around with them because they are just equations, okay? So with that out of the way, let us now proceed to past paper questions. So let's have a look at question 2. Now, this question 2 is from a 2017 June past paper. So we've got question 2 that states, if cos of theta is equal to negative 7/25 and theta is an element of 180 to 360, calculate the value of 14 tan theta with the aid of a diagram and without the use of a calculator. So there's two important pieces of information that will allow you to solve for theta, or more specifically 14 tan theta. So we are given cos theta is equal to negative 7/25. In addition to that, we are told that theta is between 180 to 360. So this is the first question, and we are already going to rely on our cost diagram. So if you remember from your cost diagram, quadrant 3 and 4 was between 180 to 360. Quadrant 3 was from 180 to 270. Quadrant 4 was from 270 to 360. So what this means is that our triangle needs to be drawn either in quadrant 3 or in quadrant 4. We're not sure as yet. We need to first figure it out between quadrant 3 or quadrant 4. Now, what will allow us to figure that out is the identity that we are given. So as you can see, the identity is cos theta equals negative 7/25. So when is cos negative? Is it negative in quadrant 3 or is it negative in quadrant 4? Now, if you remember from your cos diagram, cos was positive in quadrant 4. And because we are dealing with a negative identity, it means that our triangle cannot be in quadrant 4. So that is how you are now able to narrow down between quadrant 3 and quadrant 4, which quadrant will your triangle be in. So we can now conclude that because cos is positive in quadrant 4 and we are dealing with a negative identity, that means that this identity is in quadrant 3. And we know that only tan is positive in quadrant 3, which means that sine and cos are negative. So we can now draw this particular triangle within quadrant 3. So this is our triangle within quadrant 3. Keep in mind that the right side will be your positive x side, the left side will be your negative x side, the top will be positive y, and the bottom will be negative y. So keep that in mind. That will help you in identifying which value is negative, and it will also help you if you were to use Pythagoras. It will tell you which value to choose from, because remember, your answers in Pythagoras always end in positive or negative. Let's denote this as theta. And let us see. we were dealing with cos theta equals -7/25. Okay, so from here we know that cos is equal to adjacent over hypotenuse. And from this triangle, we can see that this y is going to be our opposite. This value over here will be your hypotenuse, and this x will therefore be your adjacent. So let's label that. So this is going to be your hypotenuse, or you can denote it as R, since you're dealing with a triangle. This will be your adjacent, and this will be your opposite. Now, let us now try to put in this 7 and 25 into their correct positions. So let's start with the 25, the hypotenuse. We know that our hypotenuse is the side over here, so we can now substitute that 25. This -7 now represents our x value, our adjacent. So let's substitute that in. So this will be -7. So as you can see, our value of y is missing. We do not have a value of y. So we can now use Pythagoras in order to find the missing side. So our theorem of Pythagoras is the hypotenuse squared is equal to the adjacent squared plus the opposite squared, and that is Pythagoras. From here, we can now go and substitute. We were told that the hypotenuse is 25. So we can substitute 25, don't forget to square, equals our x value, which is -7. Don't forget to put the negative in the bracket as well. If you just do this, -7 squared, you would end up with -49. That is incorrect. Keep in mind that this is supposed to be in brackets. That way it will result in +49. So please don't make that error. Plus y squared. From here, we can simplify this. So we'll take the -7 over to the other side, and it will then become, let's see, we've got 25 squared. That is going to become 625. Minus, we've got -7 squared. That is going to give us 49 is equal to y squared. So we can simplify this, put this into our calculator, square root both sides, and we will then end up with, let us see, we will end up with positive or -24. So how do we know whether our answer is supposed to be +24 or -24? That depends on the position of that particular side. So if our triangle was in quadrant 1 and quadrant 2, whereby we would be dealing with the positive y-axis, we would have chosen the positive y value. But because we are dealing with quadrant 3, whereby we are dealing with the negative y value, we are now going to choose y equals -24. So let us substitute that or put it into our triangle. So this is now our value of y. The whole goal of finding or completing this triangle was in order for us to simplify and find the solution of 14 tan theta. Let's just double check if that's the correct question. Yes, it is 14 tan theta. So in order for us to find the value of 14 tan theta, because the question specified use the aid of a diagram, we then drew our diagram, identified which quadrant the triangle is in, substituted or put in the values of those particular sides, our hypotenuse, our adjacent, and our opposite, and then found the missing side. In most cases, there'll always be a missing side, so I would highly recommend knowing how to use Pythagoras. If you don't know how to use Pythagoras, you can go back to a grade 9 or grade 10 textbook. I believe it was introduced in those grades, and you can have a look at it there to refresh your memory. So always remember, step number 1, find out which quadrant your triangle is in. After you find out which quadrant your triangle is in, label the sides and put the values of those sides so that you are able to identify which side is missing. Once you identify which side is missing, you can use Pythagoras in order to find the missing side. Now take note, Pythagoras will result in a positive or negative value because you are square rooting. Remember, when you square root, it's always going to give you plus or minus of that value. Once you've simplified and you've got your plus or minus of a particular value, you need to go to that side and identify, okay, is this side in the positive or the negative area? Once you've identified whether it's in the positive or negative area, you are then able to finalize or conclude on whether you are taking the positive or the negative value. That is all you need to do. That is the prep work in order for you to actually start answering your question. So now let's have a look at our question. We are dealing with 14 tan theta. Now, if you remember, when we were dealing with SOHCAHTOA, we previously mentioned that tan is equal to opposite over adjacent. So let's sub that in. So our tan theta, so we're going to bring down the 14. Don't forget about it. And our tan theta is opposite over adjacent. From here, we need to substitute what is the value of our opposite, what is the value of our adjacent. So our opposite has a value of negative 24. And our adjacent has a value of negative 7. Now, once you put this into your calculator, 14 times negative 24 over negative 7, you will then end up with positive 48. So that means that 14 tan theta is equal to positive 48. Okay, now that is just question 1. All we needed to do for question 1 was rely on our knowledge of our quadrants, Pythagoras, and SOHCAHTOA. So if at any point in time you do not understand something, if you need me to repeat something or to elaborate or to try and answer it in a different way, you're more than welcome to unmute yourself and speak up, and we will try and resolve whatever confusion you have with that particular question. If you are sending a message in the chat box, if you are feeling too shy to speak up, I would recommend referencing the question number. So if you are dealing with, or if your confusion is related to 2.1, just reference question 2.1, then ask your question, okay? And I will post the solutions, the screenshots in the WhatsApp group. If you are not in the WhatsApp group, you can WhatsApp me to add you to that specific group. But when you WhatsApp me, please be specific on which group you are referring to. If you are referring to the grade 11 group, state grade 11 group. So I've left my number in the chat box. If you are not in the WhatsApp group, you can message me and I will add you to the group. So let us continue with question 2.2. So if we look at question 2.2, it's a simplifying question. So this question is going to rely on our reduction formula from our cost diagram. Now we've got question 2.2, simplify without the use of a calculator. So let's just have a look at these identities or these reduction formula before we actually go and solve the question. So as you can see, we are dealing with 90 plus x. So that's the first one that we need to deal with. Now, if you think back to our cost diagram, those are one of our co-ratios. 90 plus x was in quadrant 2. Now, our next one is 180 plus x. That is in quadrant 3. At the bottom, we have numerical reduction, 225. So we need to ask ourselves which quadrant is 225 in. As you can see, 225 is bigger than 180, but less than 270. Therefore, it is in quadrant 3. And lastly, we've got this negative x. Now that negative x is from our negative cost diagram, our negative angles. So if this is our cost diagram, our negative angles will be moving in the clockwise direction. This would represent negative x. So that is in quadrant 4. So because we know that cost is positive within quadrant 4, this will then be positive. So let us attempt to solve this particular question. So we've got cos of 90 times sine of 180 plus x all over tan of 225 minus cos squared of negative x. Okay, so this is our question. Now, as we mentioned previously, this is in quadrant 2, this is in quadrant 3, this is in quadrant 3, and this is in quadrant 4. So let's start. Now, cos of 90 plus x. We ask ourselves, what quadrant is this in? We know that it's in quadrant 2. And is cos positive or negative in quadrant 2? We know that it is negative in quadrant 2. So we put our negative sign. From there, because we see that 90, we therefore know that we are dealing with a co-ratio. So we can convert from cos, it is then going to change to sine. And we bring down our variable. So that is the first part. Next, let's have a look at sine of 180 plus x. So we ask ourselves, which quadrant is this in? We know that sine of 180 plus x is in quadrant 3. And we know that sine is negative in quadrant 3. The only thing that is positive in quadrant 3 is tan. So we'll draw a little cost diagram here to help us. CAST. So we know that tan is only positive in quadrant 3. Therefore, this is going to become negative sine x. And that is all over. Now we need to reduce tan of 225. So we ask ourselves, what quadrant is it in? We know that it is in quadrant 3. So we then ask ourselves, is it positive or negative within that quadrant? So if we have a look at quadrant 3, we can see that there's a little t indicating that tan is positive. So we can put a positive tan. Now we need to reduce this angle. So let us reduce that on the side. So we are dealing with 225. So what is the reduction formula within quadrant 3? We know our reduction formula is 180 plus theta equals, we equate that to the angle that we are reducing. So that's all you need to do. When you are reducing a numerical value or a numerical angle, all you need to do is figure out which quadrant it's in and equate your reduction formula to that angle. From there, all you need to do is solve for theta. So if you take 180 to the other side, and you'd have 225 minus 180, therefore giving you a value of 45. So that's all you need to do. Step number 1, identify which quadrant it's in. Step number 2, identify your reduction formula, then equate your reduction formula to that angle and solve for the theta value. Or if you like to use x or whatever representation of an angle you prefer to use within your reduction formula, just solve for it, okay? So that's the 225. It now becomes 45. From here, we can bring down the minus sign, and now we have cos squared of negative x. So whenever I'm dealing with a squared identity, I like to move the squared to the outside. So I've got cos of negative x and then square it. From there, I can simplify what's on the inside, then square. So if I look at the inside, I've got cos of negative x. I know that cos of negative x is within quadrant 4. And we know that cos is positive within quadrant 4. Therefore, this is now going to become positive cos x. From there, I can then go and square this, so it'll then become cos squared x. Now, please don't change this negative sign to a positive sign. That is from the question. It is not from the identity. That negative sign is from the question. All you need to do is bring it down. Do not change it. Just bring it down. Leave it alone. Okay, so let's put tan of 45 into our calculator. So if we put tan of 45 into our calculator, we will end up with 1. So we are now going to substitute 1 in this position. So before we do that, let's simplify our numerator. We've got negative times negative, which gives us positive. We've got sine of x times sine of x. That gives us sine squared x. Over, we now convert this tan 45 to 1 minus, we bring down the cos squared x. From here, this should look familiar to you because it is an identity. It stems from cos squared x plus sine squared x equals 1. If we want to try and simplify for 1 minus cos squared x, let's move the cos squared to the other side, leaving us with sine squared x equals 1 minus cos squared x. So we can now see that 1 minus cos squared x is equal to sine x. So we can substitute sine x into that position. So let us do that. So we bring down the sine squared x on the numerator, and we substitute our denominator as sine squared x. From here, you can see that the top cancels out the bottom, and you are finally left with 1. An alternative would have been to convert this, or to convert the numerator into 1 minus cos squared x, and then cancel out top minus bottom. That would have been completely acceptable as well. So all we needed to do was simplify this particular expression, and we ended up with 1. Let us now move on to question 2.3. So we've got question 2.3 that states, determine the general solution of 2 cos 2 theta equals negative 0.44. So let's attempt that. So we've got 2 cos of 2 theta equals negative 0.44. So all we now need to do is look at this as though it is an equation. Okay, so just give me a moment. I saw there was a question in the chat. How do you know that the angles are in which quadrant in question 2.2? Okay, so let us go back to question 2.2 quickly. Ntokozo, when you say the angles, are you referring to the numerical angle whereby we had 225, or are you referring to the reduction formula angles whereby we had like cos of, no, we had that 90 plus x, 180 plus x? Which one do you want to know? How do we identify which quadrant it's in? Both. Okay. So the question being asked, for those that did not hear or did not see the chat box, one of your classmates wants to know, how do we find which quadrant these particular angles are in? Now, if you remember, when we first started the session, we dealt with our cost diagram. Now, our cost diagram was split up into 4 quadrants. This being quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Now, we know that this is a full circle or revolution, therefore it's going to be 360. And each quadrant is broken up into 90 degrees because we've got a total of 360, 4 quadrants. You just divide 360 by 4, right? So this is from 0 degrees to 90 degrees to 180 to 270 and finally 360. Now, there's no way of looking at a question and identifying which quadrant it's in if you do not know your cost diagram. It is extremely important for you to know your cost diagram in order for you to identify which quadrant or what is going on in this particular case. So we've got our first quadrant. We know that our reduction formula within our first quadrant is theta and 90 minus theta. In our second quadrant, we have 90 plus theta and 180 minus theta. In our third quadrant, we have 180 plus theta, and in our fourth quadrant, we have 360 minus theta. It's something that you have to memorize. It's something that you have to go into the exam already knowing. So your cost diagram should already be in your head, or you should already have memorized your cost diagram. So let's have a look at that. If we look at our cost diagram and try to reference it to the question, our first question is 90 plus x. As you can see, 90 plus x, here it is, 90 plus an angle. That's quadrant 2. If we look at our next question, we've got 180 plus x. 180 plus an angle, that is quadrant 3. If we look at now this negative x, that stems from your negative quadrants or your negative cost diagram. This would be negative theta. This would be 180 minus theta, and this would be negative theta minus 180 and theta minus 360. So it's something that you have to already know. Now, if you look here, this negative theta and this negative x, it's in quadrant 4. So all you're basically doing is, it's kind of like a comprehension. You're just going, this is the comprehension, and you're just pulling out your answers from the comprehension. That's all it is. You're just choosing values. Now, if you look at 225, this is a numerical one, so it's slightly different as compared to the reduction formula that we were previously dealing with. So that 225, you now need to ask yourself, okay, 225, is it between 0 and 90, or is it between 90 and 180? Or is it between 180 and 270? Or is it between 270 and 360? So as you can see, 225 is in the 200s. So we know that this quadrant over here, if it's bigger than 180, as you can see, 225 is bigger than 180, but less than 270. And you can see 225 is in fact less than 270. So that is how we identify or figure out which quadrants our angles are in. The most important thing is to be able to know or to be able to pull values from your cost diagram. If you don't have your cost diagram in your head whereby you can just extract the values, I would highly recommend writing it down on your exam paper and then just looking at it from there. Please don't go into the exam with a cost diagram already written out. If your teacher has not allowed you to do so, as you will most likely get into trouble, as that is academic misconduct. It's cheating within an exam. So memorize it or learn it before you get into the exam room, okay? Now, let us move on. Now, our question 2.3, we needed to find the general solution of 2 cos 2 theta equals negative 0.44. So all you need to do is look at this as though you would look at a normal equation in algebra. So let's say, for example, we made this cos 2x, let's say we made it x. So if this is 2x equals negative 0.44, what would you do in this particular case if you were solving for x? Would you not just divide by 2 on both sides? So you do the exact same thing in your trig equation. So we're going to divide by 2 on both sides, and that is then going to give us cos 2 theta equals negative 0.22. Now, next step, because we've simplified for the identity as far as possible, we can't simplify this identity any further at a grade 11 level. We now need to ask ourselves, is cos equal to something positive, or is it equal to something negative? Now, as you can see, it is equal to a negative value. So what quadrants is cos negative in? So let's draw our cost diagram. So you can see that once again, we're making use of our cost diagram. So what quadrants is cos negative in? Cos is negative in quadrant 3 and quadrant 2. That means that our answers are going to be in quadrant 2 and quadrant 3. So before we even get to that point, we need to find a reference angle that we can use in order to find the solutions in quadrant 2 and 3. So when you are finding a reference angle, do not include the negative. So let us find our reference angle. Our reference angle is just taking cos to the other side. When you take cos to the other side, it's going to become cos inverse. So on your calculator, you put cos inverse of 0.22. Do not include the negative sign. And that then becomes your reference angle of 77.29 degrees. This is our reference angle. Okay, that is extremely important. Please take note of that. Do not include the negative sign. If you put the negative sign in, you're going to end up with a negative reference angle, and we do not want that. We always want a positive reference angle, so always leave out the negative sign. This negative sign is only there to tell us which quadrants our answer is going to be in. So let's start. Our first answer is going to be within quadrant 2. So we put our angle, which is 2 theta, equals something important. When you're finding your reference angle, don't divide by this 2. If you have 2 theta or theta plus 1, theta minus 1, leave it as that. Whatever is the angle, whatever comes after your identity, that is what you bring down into your quadrants. Leave it alone. Don't simplify for it as yet. You only simplify for that part at the end. So I'll repeat once more. Whatever comes after cos or sine or tan, whatever is in this angle position, whatever is in this angle part, always bring that down with you. Don't solve for it at the beginning. Always solve for it at the end, okay? So let's continue. We've got 2 theta is equal to, now within our first, or more specifically within our second quadrant, our reduction formula is going to be 180 minus an angle. That's our reduction formula. And then we add plus k times 360. If we were dealing with tan, we would have said plus k times 180. So always remember, sine and cos is k times 360, tan is k times 180. Now, let's simplify this. So we bring down this 2 theta is equal to, now this angle represents the reference angle. So we have 180 minus, now we're going to substitute our reference angle of 77,29 plus k times 360. From here, we now simplify the right-hand side. So we've got 2 theta equals, so on our calculator, we put 180 minus 77.29, and that gives us 102.71. Plus k times 360. Now, we cannot simplify the right-hand side any further. So this is when we divide. This is when we now try to simplify the left. So once you've simplified the right as far as possible, that's when you start to simplify the left. So we divide by 2 on both sides. If it was something like theta plus 10 equals this 102,71 plus k times 360, we would have moved the 10 to the other side, making it minus 10 on the right. So keep that in mind, that your normal algebra rules still apply. So from here, we end up with theta equals, so we'll divide that by 2, we get 51.5 or 51.36. So 51,36 plus, now we divide 360 by 2 and we end up with k times 180. Now, at the end, you just put k, an element of integers. That is the first solution. That is our solution within quadrant 2. So we made a dot in both quadrant 2 and 3. So our next solution is going to be in quadrant 3. So quadrant 3, what is our reduction formula within quadrant 3? It's 180 plus an angle, and then we bring down this plus k times 360. From here, we can substitute. We know this angle refers to our reference angle. That is why it was extremely important for us to first calculate the reference angle at the beginning. So we substitute our reference angle of 77.29. Once we substitute our reference angle of 77.29, we can therefore put that into our calculator. So 180 plus 77.29 gives us 257,29 plus k times 360. From here, because we've simplified the right as far as possible, we can now divide by 2 to simplify the left. So we therefore end up with theta equals to, so we're going to divide that by 2 and end up with 128,65 plus k times 180. And don't forget to put k, an element of integers. So these are our general solution answers within quadrant 2 and 3. If cos was equal to a positive value, we would have used quadrant 1 and 4. So let us do a quick recap of what we did and how we solved for this particular general solution. So we've got our general solution of 2 cos 2 theta equals negative 0.44. From there, we needed to treat it as a normal equation. We just divide by 2 on both sides. From there, we identified that our cos 2 theta was equal to a negative value, which means that our solutions will be in the quadrants whereby cos is negative, meaning quadrant 2 and quadrant 4. If we had cos 2 theta equal to a positive value, it would have been in quadrant 1 and 4 because those are the quadrants that cos is positive in. From there, once you've identified which quadrants your solutions are going to be in, you therefore need to find your reference angle. How you find your reference angle is just taking cos, tan, or sine to the other side, making it sine inverse, cos inverse, or tan inverse, depending on what you are dealing with. From there, always remember, do not include the negative sign when you are finding your reference angle. So once you found your reference angle, that reference angle was then going to be used within quadrant 2 and 3 to find the solution. So let's start with quadrant 2. In order for us to find our solution in quadrant 2, we needed to make use of our cost diagram. So as I previously mentioned, you're going to use your cost diagram in almost every question within trigonometry. And as you've seen, we've used it in question 1, question 2, and now question 3. So your cost diagram is extremely important. I would highly recommend that you go and learn your cost diagram. So let us continue. Once you put in your reduction formula for quadrant 2, you then need to add k times 360. That part of k times 360, that is a general solution thing. That allows you to find an answer using any rotation. So if you were to rotate this 360 degrees, you can then find the solution in quadrant 2 again, but for a bigger angle. Basically, what that means is you were able to find a solution for any rotation. You know that angles don't stop at 360, they continue, right? If it goes beyond 360, it's going into the second rotation. If it goes beyond, it can go until infinity. It keeps rotating and rotating. So this allows you to find a solution for any rotation. That K, that just represents the rotations. If you're dealing with rotation 1, you will put a 1. If you're dealing with rotation 2 or your revolution 2, you'll put a 2. This allows you to identify or to find a solution for any angle within that quadrant 2 or quadrant 3. So let's move on. Once we've simplified the right-hand side as far as possible, we then try to simplify the left-hand side. So because we have 2 in front of our theta, we divide by 2 on both sides, which means the angle gets divided by 2 and that k times 360 gets divided by 2. Keep in mind that if we were dealing with tan, it would have initially been k times 180. Keep that in mind. Now, let's move on to quadrant 3. Within quadrant 3, we did the exact same thing. We introduced our reduction formula within quadrant 3 as well as plus k times 360. From there, we were able to substitute our reference angle, simplify the right-hand side as far as possible, then simplify the left-hand side. So that is our reduction, or more specifically, our general solution. Okay. Now, I did see there was a question in the chat, so please give me a moment to respond. How did you get from negative cos squared of negative x to negative cos squared x? Referring to question 2.2. Okay, so question 2.2, how we went from, let's see, cos squared of negative x. Okay, let's redo that quickly. I did erase that. Okay, so we had negative cos squared of negative x, but this negative was from the question, so just leave it out, don't include it. Just deal with cos squared of negative x. Leave the question's negative alone. Now from here, what I like to do when I'm dealing with a squared identity is I like to move the squared to the outside of a bracket. So I'll have cos of negative x all squared. This allows me to simplify the inside, then square it again. So I've removed the square and put it on the outside. I'll bring it back to the inside at the end. So from here, I've got cos of negative x. So we know that cos of negative x is our fourth quadrant, and cos is positive within the fourth quadrant. So this now becomes positive cos x and squared. So now we bring the squared back inside and we get cos squared of x. That is this part over here. This negative sign comes from the question's negative sign. Okay, so let's go back to our question. So we completed 2.1, 2.2, and 2.3. Let's have a look at 2.4. So question 2.4. Okay, so with question 2.4, we need to prove that the left-hand side is equal to the right-hand side. So because the left-hand side looks most complicated, we're going to start there. Whenever you're dealing with prove that the left-hand side is equal to the right-hand side, or the right-hand side is equal to the left-hand side type question, all you need to do is start at the side that looks most complicated. It's easier to simplify and break down as opposed to build up. Because if we were to start on the right, all we could do is change tan theta into sine theta over cos theta. There's nothing much that we could do beyond that point, because we get stuck. It's difficult to build. But if we look at the left-hand side, we can start breaking up. We can break things apart on that side. So let's start on the left-hand side. So we've got all over 1 minus cos theta equals tan theta. We need to prove that that left-hand side is equal to the right-hand side, and we are starting on the left. So as you can see on the left-hand side, we've got this identity of tan theta. We know that tan theta is equal to sine theta over cos theta. So that is what we are now going to substitute. So in place of tan theta, we're going to substitute sine theta over cos theta. And that is all over 1 minus cos theta. From there, we can use three-way multiplication. So we want to find a common denominator. So this is over 1. I'm going to multiply cos and sine. I'm going to multiply 1 and sine, and I'm going to multiply the denominators. So that is then going to give me sine theta minus sine theta cos theta all over cos theta. And that is all over 1 minus cos theta. Now, because I'm dealing with a fraction over a fraction, I'm going to rewrite this as two separate terms. So I'm going to rewrite this as sine theta minus sine theta times cos theta all over cos theta divided by 1 minus cos theta. So instead of having fraction over fraction, I'm just going to separate the terms. Now we know that whenever you are dealing with division, you can turn it into multiplication. So that is going to be sine theta minus sine theta times cos theta all over cos theta times 1 over. Now, when we turn division into multiplication, we're going to put this over 1. So it's going to be 1 over 1 minus cos theta. Something else that I want us to do is to simplify the numerator section. So instead of just leaving it as is, I want us to simplify it. So as you can see, sine is a common factor within the numerator. So I'm going to take out that common factor, and I'm going to be left with 1 minus cos theta. Because if you take out sine from sine, you are left with 1. If you take out sine from sine cos, you are left with cos. Now, as you can see, this cancels out this. So we are then left with sine theta over cos theta, which is equal to tan theta. And if we go back to the top, that is what we wanted to find. We wanted to prove that that left-hand side is equal to tan theta. So we can conclude that the left-hand side is equal to the right-hand side. Now, let us go and read question 2.5. So question 2.5 states, if alpha plus beta is equal to 90 degrees without, or rather determine without the use of a calculator, cos of 700 over sine 70 minus sine alpha over sine of 90 minus beta. So let us now try to simplify that. So once again, we are also going to make use of our cost diagram. So important information that we were given was that alpha plus beta was equal to 90 degrees, I believe. Let's just go back and double check if it is 90. Yes, it is 90. And our question is, I think it was cos 700 over, let's see, sine 70, okay. Minus sine of alpha over, I think it was cos of 90 minus beta. Let's double check. Yeah, sine alpha over sine of 90 minus beta. Okay, so this is sine, not cos. So let's change this. So this is our question. We've got our important piece of information at the top. We've got alpha plus beta equals 90 degrees. And our question at the bottom is cos of 700 degrees over sine of 70 degrees is minus sine alpha over sine of 90 minus beta. So if you look at that 90 minus beta, you can see that it's quite similar to what we have at the top, that alpha plus beta equals 90. We know that if we were to try and solve for alpha, we'd end up with alpha equals 90 minus beta. So we can actually substitute this alpha into this position, giving us sine alpha over sine alpha. Okay, that is why that piece of information was important. So let's have a look at the left-hand side first. So on our left, we've got cos of 700 700. So all you need to do is, because it is greater than 360, whenever you are dealing with an angle greater than 360, all you do is subtract 360 continuously until you get an angle smaller than 360. So 700 is bigger than 360, so we are going to subtract 360. So we have 700 minus 360, and that gives us 340, which is smaller than 360, so we can stop there. So 700 minus 360 gives us 340. All we are doing is removing one rotation, so we'll end up back in the same position. We'll end up back in the same quadrant. Think of it like this. 700 is in quadrant 4. If we were to subtract 360, so this whole revolution, we subtracted it, we end up back at the same place. So technically, we've not changed anything. So this is now going to be cos of 340 over sine 70 minus sine alpha over sine alpha. In place of 90 minus beta, we are substituting what 90 minus beta is equal to, which is alpha. Now, from there, let us try to simplify this 340. Let us try to reduce it. Now, 340 is in the fourth quadrant. We know that the reduction formula within the first quadrant is 360 minus an angle, and we equate that to what we want to reduce, which is 340. From here, we can solve for theta. So we're going to end up with 360 minus 340 is equal to theta. And finally, we have theta as 20 degrees. So let's substitute. We've got cos of 20 over sine of 70 minus. Now, here we've got the top cancels out the bottom. So we will then be left with 1. Now, what do we do from this point? Because we were told we're not allowed to use our calculator. And we can see that 20 and 70 are not special angles. So we can't use our special triangles to solve for that. So something important that you should notice is that 20 plus 90 adds up to, 20 plus 70 adds up to 90 degrees. Always remember, or always train your brain and your eyes to identify any sum or any difference that gives you 90 degrees. If ever you have any two angles that gives you 90 degrees, always think of co-ratios. So technically, what is going to happen here is cos 20 is going to cancel out sine 70. The reason being is that we can convert cos 20 to sine 70, making it sine 70 over sine 70, or we can convert sine 70 to cos 20, making it cos 20 over cos 20 and cancelling out. Always remember though, that it cannot be the same identities. For example, if we had cos of 20 over cos of 70, these two cannot cancel each other out. It has to be different identities. So there's two rules. The angles have to add up, or when subtracted give you 90 degrees, and the identities have to be different. One has to be cos, one has to be sine. So let us now try to prove this. I'm going to convert the cos 20 into sine 70. So we've got cos of 20 degrees. If we want to convert this, it's going to be cos of 90 minus 70, because technically it's still the same thing, right? 90 minus 70 is still the same 20. If you subtract, put it on your calculator, 90 minus 70, you get 20. So technically, I've not changed anything. Now, from here, because we've got a 90, we know that we're going to deal with co-ratios and convert. So we ask ourselves, 90 minus 70 or 90 minus an angle or 20 degrees, what quadrant is that in? We know that is in quadrant 1. 20 degrees is greater than 0, but less than 90, therefore it is in quadrant 1. So we know that cos is positive in quadrant 1. And then because we are dealing with a co-ratio, we convert from cos to sine. Always remember, this is the angle that you bring down. Okay. So this is now going to give us sine of 70 over sine 70 minus 1. From here, top cancels out bottom, and you are left with 1 minus 1, therefore giving you 0. So that is all we needed to do. This question relied heavily on co-ratios, so I would highly recommend knowing your co-ratios. As you've seen, I think we've used co-ratios in question 2 and question 5, so it is something that is frequently used. If you did not know how to use co-ratios, you would have lost this full 5 marks, and 5 marks is quite a lot. So for this particular question, all we needed to do was identify that 90 minus beta is alpha. Once we've substituted alpha in place of 90 minus beta, we were then able to cancel out the top, cancels the bottom, resulting in -1. If we look at the right hand side, we were supposed to see that 700 is in fact greater than 360. So because 700 is greater than 360, we need to keep subtracting 360 until we get something less than 360. In this particular case, we only needed to subtract 360 once. But if we were dealing with an angle bigger than 2000, we would have most likely had to subtract 360 multiple times. If we were dealing with an angle bigger than 1000 even, we would have had to subtract it about 2+ times. Now, once we reduced 700 to 340, we could then reduce it even further because we know our reduction formula in quadrant 4. That is 360 minus theta. Whenever you are reducing a numerical angle, always take that reduction formula within that specific quadrant and equate it to whatever angle you are reducing. In this particular case, we are reducing 340. So we need to take our reduction formula in quadrant 4, which is 360 minus theta, or minus any representation of an angle that you want to use, and equate it to 340. From there, we can solve for the angle, and that is the reduced angle. That is how we ended up with cos of 20. From there, we were then able to see, okay, I've got 20 on top, 70 at the bottom. I know that is co-ratios because 20 plus 70 gives me 90, and I'm dealing with two different identities. So from there, you do not need to do this thing in blue that I did on the side. This was just for you to be able to see why it cancels out. In a question, all you need to do is this. All you need to do is this. This cancels this, and you can move on. So this step here was just an additional step for your understanding. You do not need to do that step. You can go straight from cos 20 over sine 70 minus 1 all the way there to minus 1 minus 1 equals 0. So that additional step was just for your understanding. You do not need to include it in a question. So from there, we ended up with 1 minus 1, which then gives us 0.